In this video, we're going to look at how to name ionic compounds. So we've talked about ions now. If we think generically, an ionic compound is going to be composed of one cation, at least, so the cation's got to have a positive charge, and one anion, at least. So the anion will have some type of negative charge on it. So positively charged side and a negatively charged side. And is that electrostatic attraction that holds them together. So if we look at an example, let's say that we have NaCl. So Na is Na plus, that's the cation, and Cl is Cl minus, that is the anion. So we know now that species elements that are on the left-hand side of the periodic table tend to lose electrons and become cations. Those that are on the right-hand side tend to gain electrons and become anions. So when naming ionic compounds, the cation is just going to have its normal name. So that's a sodium ion, but we're just going to say sodium. And then that's a chloride ion. So instead of chlorine, we're going to change the end to IDE. So this is chloride. So that tells me that it's the anion. So the name of that compound is sodium chloride. Let's look at another example. Say that we have calcium and oxygen. So again, calcium is going to be 2+ here. That's the oxidation state of calcium. It's a group 2 metal, so it will lose 2 electrons to get back to that noble gas configuration. So that is the cation. And then oxygen will gain 2 electrons to get to the noble gas configuration. So that's going to be O2-, and that makes sense because 2+ and 2- cancel each other out. So as a unit, it's neutral. So this is my anion. And so the name of this compound will be calcium oxide. So the "ide" tells me it's the anion, and again the cation just has its normal metal name. There are a few metals that can have more than one oxidation state. This is my with sign. Which means that we need to note which oxidation state that metal is in the ionic compound. So for example, we could look at FeCl2. Okay? Now iron, Fe here, is going to be the cation. It's the metal, so it tends to lose electrons. And the chloride is going to be the anion. I said "ide" because the anion. Now I know that a chloride has a -1 charge, and there are 2 of them. So from the chlorides, I have a total -2 charge, which means that to be balanced and neutral, that iron must be in the +2 oxidation state. So to name this guy, I would say iron, and then I put in parentheses Roman numeral 2 chloride. And because of that, I know that the iron is in the 2 oxidation state, which tells me that there must be 2 chlorines in that formula unit. Now iron is also capable of being in the +3 oxidation state. So here we know that the chloride ion is -1, and there are 3 of them. So that gives me a total charge of -3 from the chlorides. So the iron, to be neutral, this whole unit has to be +3. So this guy would be called iron 3 chloride. So when you have a metal that can have more than one oxidation state, you need to note what oxidation state it is in by showing a Roman numeral after it like this. So the common metals that can do that are iron and copper. Okay, so that's the ones you'll probably run into most of the time. And we'll talk about in class which ones can do that and which ones can't. But these are the main ones. And then we're going to do a quick example where we have a polyatomic ion here. So here I have calcium, okay, and calcium is a group 2 metal, so I know it has a +2 charge. So this whole thing has a -2 charge. So here, let me change pen colors here. I have my metal, and that is a cation, and then I have my nonmetal, and that is my anion, and this is called a polyatomic anion because it has more than one atom in it. So the whole anion has carbon and oxygen in it, so poly just meaning multiple. Okay, so the polyatomic anions, what you're probably going to have to do is just memorize what their names are. So that particular guy is called carbonate, so this is called calcium carbonate. So there's a nice table in your book that gives you the names of the very common polyatomic anions. And you're just going to use whatever that name is as the anion part of the name. Polyatomic anions can also be positively charged. So if we look at this example here, we'd recognize bromine or bromide at the end, so that's a -1, so this whole thing must have a +1 charge. The name of this is ammonium, which is the name of that polyatomic NH4+ ion, and then bromide. Since it is just a normal monoatomic anion, we end with that "ide" there. So this tells me that it's just a monoatomic anion, and then the NH4+ is polyatomic, and in this case it's the cation.